Hello everyone, this is a video lecture for Algebra 1314. We're going to be doing section 1.5, which is the last section that we're covering in chapter P and 1. And so we're going to do quadratic, what? Quadratic equations is this guy. Quadratic formula is right there, ha ha ha. It's not letting me draw, oh well. Ha ha ha. There you go. So we're going to do that here in a little bit. But first, we need a word from our sponsor. No, I'm just joking with you. I'm just having fun. Desmos. Today's sponsor is Desmos. And Desmos is super awesome. So we're going to be using Desmos for a whole bunch of this. When it says solve, again, that's what we're doing here is still solve for x, okay? But there is no way that Desmos will do all of this for you, especially when they start saying quadratic formula. So I do want to show you the weaknesses of Desmos, but also the strengths, okay? So there's a lot of blah blah here. Go have fun with that blah blah. I think that this is actually pretty important. Notice that if I square root both sides, I have to have a plus and minus. When I square root both sides, I have to have a plus and minus. That's important. That's important, okay? Let's keep going. So it says use factoring to solve. And what it means by use factoring to solve here in this class, it means Desmos. No, I'm playing. But I mean, in a funny way, it does actually work for some of these problems. I don't want to shy away from Desmos. I'm even typing in the 0. And it works, and we're done. That was it. We did it. Yay. But there's no way I'm going to let you do that. I mean, well, I can't really stop you. But there's no way I'm going to let you off the hook. We are going to do this by hand. But I can't shy away from this either. I got to show you Desmos whenever it is appropriate. Okay? So I am going to factor. I am. I'm going to say, hey, what two numbers multiply to 72 yet add to a 1? And so you're thinking, dun, 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 dun. Okay, yeah, I don't know, actually. 8 times 9? Oh my gosh, how did I know? Well, there's the answers right there. I know I'm kind of cheating a little bit. That's fine. 8 times 9 is 72. And can I manipulate these to get to a 1? Yes. In fact, to get to a negative 1 in particular, I'd say a positive 8 minus 9. And notice that it's positive and negative. So I've got x plus 8, x minus 9, and then this is equal to 0. Now pause for a second here. We got to still get to our answers. We just factored it. Now solve for x. And you've done this before. I'm sure of it. If you've gotten to this point, this is what you do. I just simply switch the signs. And I say, oh, well, that's a negative 8. Oh, yeah, this is a positive 9. And we're done. There you go. There's your answers. Why do we switch the signs is because the 0 essentially applies to each one of those factors individually. And so I'm saying that this guy here is equal to 0, and so I minus 8 on both sides, so x is equal to negative 8. Same thing with a 9, basically, just move it over. So you switch the signs of the factors and you get your answer. Did I get my same answers from Desmos? Yes. All right, let's do it again. This time, notice that it's a little different looking. And there is an equal sign somewhere in the middle. Yet again, Desmos is for the win. What I'd have to do by hand, though, is to move them both over first so that I can factor them. What two numbers multiply and add? Well, this is 7 and 3, and I think I can make that work for that. So negative 7 and a positive 3. Again, solve for x by switching the signs of your factors. Did I get the same answers? Sure did. Man, I love today's sponsor. Do you? Do you love today's sponsor? Do you? Do you love today's sponsor? Come on. Woo! There it is. Oh, man. Do you want to factor this one with a 16? Come on. Nobody wants to do that. I will still, I guess. It just hurts my heart, man. But I gotta say, Desmos is actually really, really close here. Yes, it gave you decimals. Yes, we need a fraction. But I'm looking right here, and I got negative 0.5. Surely Surely there's a fraction for that guy, and there is. There you go. You got it. So let me write these down so that I have them. That's a negative 1/2. And then back to this guy again. 375. So 0.375. Does that also give me a fraction? And it does. Look at that. That looks pretty. Now I'm going to go back and verify these. I got to say that if you got something else, and here's an example. What if I got like this? And like, oh, well, that's my answer for sure. It's not your answer for sure. I'm sorry. That's not your answer for sure. That's not it. But sometimes when you have things like that, and that's a repeater, you just have to... Oh, okay, never mind. I got it. So, yeah, there you go. If you put enough of them, I guess it'll work. You got to know Desmos graphing. You got to know how that works. So, again, if you see something like 333, well, then you're probably thinking that it's repeating. You know what I mean? Because you've seen it before. You've done these things before. Okay? So, I want to do this by hand, of course, and it's not fun. Not fun. In fact, before I keep going, I want to go into the workbook and see what I did here, because, like, man, I did the AC method. Oh, gosh. So, here we go. 16 times 3. That's a gross 3, but I'm leaving it. 48. So what are the factors of 48? I got 1 times 48. 2 times 24. Got 3 times 16, I think. Yep. 16. 4 times 12. There's no 5s. I think there's a 6. Times 8. Yep. Okay, out of these guys, what makes a 2? And it's these guys right here. And so I can then rewrite this as a negative 6 and a positive 8. And just pause for a second here. I have to say that there's a lot of questions. Hey, which one do I put in front? Which one do I put in the back? Does it matter? No, it does not matter. It does not. You will get different results than me as you move down, but we will end up in the same place in the end. Okay, so it does not matter. What do they have in common? It looks like a 2, just a 2, I think. And an x, of course. So then I got 8x minus 3. Okay, hold on. I better darn well get a 8x minus 3 out of this. I better get an 8x minus 3. Oh, I already got it. So what do they have in common? What did I pull out of there? I don't know, a 1? Just a 1. And that 1's going to be important because when I move this all to the front, 2x plus 1, there you go. That 1, that leftover 1 was important there. So now I need to solve for x. And I got to say that these are a little bit more lengthy to solve for x. Normally I just say, oh, switch of signs is done. But it's not quite done in this case. So I'm going to say equals 0. I'm going to add 3 to both sides. I'm going to divide by the 8. And there we go, 3/8. There it is. Let's do the same thing for the other one. 2x plus 1 is equal to 0. Minus 1. Divide by the 2. Negative half. There you go, negative half. We did it. Awesome. Oh, man, I don't want to do that problem. No way. No way. What are you doing to me, Chad? I don't know. Let's try. I'm also doing it right now because you can't do it here in a couple minutes, like at all. Look, that was easy. You won't be able to do this at all here in a couple minutes, so I'm really soaking it up. Okay, today's sponsor, dude. I'm trying to utilize it as much as possible while I can. And you know, like if you're on a quiz or a test and you have Desmos graphing up, I mean, go ahead and try it. I mean, it doesn't take very long to type in, and if you get the answers, cool. If you don't get the answers, well, then that's why you did it by hand. So, like we're doing it right now. Anyways, so I foiled this guy out, and so 4 times x is 4x squared. 4x times x. 4x times the 1, negative 4x, 2 times x, and 2 times 1. There you go. I want to kind of like move everything over here, so I'm going to minus the 14x. Now I'm going to add the 14x to both sides. And so I got 4x squared plus 10x, and no. Yeah, this is a 10, but plus 2 is 12. Oops. Like all of these all get together. And then this guy right here, 16. Now, this has a 4 in the front, Chad. Come on. My name's Chad. Hello. They all have a 4, actually, so I can just factor a 4 out to the front, making this problem, whoa. It's a minus. Making this way, way easier. So that's awesome. Okay, cool. So then I factor it like normal factoring. What two numbers multiply and add? And that would be a positive 4 and a negative 1. And so then when I solve, again, I'm switching my signs. I got a negative 4 and I got a positive 1. And there's my two answers. Hey, what happened to that 4 in the front there? Well, Desmos don't use it. I mean, I want to show you without like taking too much time on this. But I have this whole expression here, and I know it's tight, but what if I divided by 4 on both sides? And I mean divide by 4, it's like all the whole thing divided by 4 over there. So these guys cancel, sweet. What is 0 divided by 4? Is 0, that's right. So essentially they cancel as well. You're saying that all this right here is equal to 0, as in like normal factoring, normal answers and stuff. That 4 went away. It literally disappeared. And that's okay. That's a good thing. Okay. Oh, no. We didn't see that. No. Divide by 6 on both sides. So x squared is equal... I don't know that one. I know I should, though, right? I should. Oh, that's why I don't know it. It's not 1 through 12. So anyways, I want to solve for x. And so if you see a square and it's equal to something like that, you can square root both sides. But remember, you have to have a plus and a minus. You have to have a plus and a minus. And so what's the square root of 16 is 4. And those are your answers. And so, I don't want to put too much of an arrow here. Got a whole other problem there. What I would like to say is my answers are plus or minus 4. Like if they had, hey, x equals what? I would put a 4 and a negative 4. You might be able to put a plus minus button. I don't know what my math lab has. Just watch out, okay? Just watch out. Okay. So then, this guy. Last one, and then, okay, so let's do this. First, so I'm going to square root both sides. Again, notice that that's a square for the whole thing. I know it looks a little bit weird, but it's the square for the whole thing, so I'm going to square root both sides. And I don't have to rewrite parentheses. We just saw this one. Square root of 16 is a 4, right? So plus or minus 4. This is where I deviate from some of the other teachers, and I'm just going to do something a little bit more radical. I am going to just simply add 5 to both sides, and I'm going to retain that plus and minus as you see it. I know that looks weird, but it's still telling me that I have two different answers, because I essentially still have a plus 4 plus 5, and I have a negative 4 plus 5, not 17. And so what I have here is a 9. What I have here is a 1. And those are my two answers for x. X equals this, x equals that, and we're done. Can I put that into Desmos? Yeah, you can. So let's just do that last one right quick. Kaboom. All right. And then the last one here. And boom. There it is. You did it. Sweet. All right. Desmos ain't going to work for you anymore. So we're going to have to do all these with quadratic formula. If it specifically says quadratic formula, you ain't getting out of it, okay? Sometimes they'll say, use the method of your choice, blah, 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 blah. They don't have one of those, sorry. But sometimes they'll say that. Well, I mean, I'll try Desmos if it's up to me. But in this case, we got to do quadratic formula, and that's okay. Let me prove it to you. Today's sponsor is Desmos. And we put this thing in, and it completely fails us. It is no good. Come on. Tell me what the answers are. Come on. Oh, you want to recover this? Here, look. Is this going to let me copy? No. Control C. Control V. Oh, yeah, that's right. Look, Chad, we got a fraction. Oh, yeah. Oh, yeah, that's it. We did it, man. No, 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 no. No, you did not. That ain't it. My point is that it does not work in Desmos. So let's do it. Quadratic formula, you got to do it at some point. Now they use lowercase, I use capital letters often, but regardless, A, B, C, plug it all in. Here we go. Negative B plus or minus the square root of B squared minus 4 times A. A is a 1. C is a 7. All over 2 times A, 2 times 1. This thing right here is just going to be a negative 7. 7 squared is 49. 4 times 7, 28. All divided by 2. If I subtract the inside there, I got 21. Is it 21? Yes, it is 21. But I want to verify. All right, cool. It's 21. And I have to tell you right here, right now, we're done. We're done. That was it. What? What? It was just that easy? Yeah. Yeah, it was that easy this time. So what I'm going to do is I want to show you something. See these two numbers? Okay, so I'm going to do negative 7 plus the square root of 21 all over 2. Is that one of my answers? Yeah, there it is right there. Yeah. All right, here we go again. Negative 7. Minus the square root of 21. Plus and minus. Divide by 2. Are those my other number? That's my other number? Yeah. So I'm verifying that my quadratic formula is working. And in a way here I'm saying Desmos is helping me double check myself. I have these from Desmos. I went and did it by hand, and I got the same thing as Desmos. So that's good. I double checked my work. So Desmos is useful for that at least. There's no way that you can get this from Desmos alone. So one last thing. This is done, but it's simply because that 21, you can't break it down anymore. 21 is 3 times 7, and there's no repeaters. There's no perfect square thingies. It is done. There's nothing else to do with this problem. So just telling you ahead of time, sometimes we will have to do a little bit more math here. But let's do that on the next problem. So here we go. First off, I have to move it all over to make it into a proper format. So we got my A, my B, and my C. Here we go. So negative of a negative 2 plus or minus negative 2 squared minus 4 times 2 times negative 3 all over 2 times 2. 2 negatives make a positive. Got a 4. 2 negatives will make a positive again. 8 times 3 is 24 all over 4. And I could do that as well. Real quick, I'm going to try to squeeze it. That's a 28 all over 4. Now, is this your answer? No, actually, I'm going to say no. It's not. It's not your answer because we have to keep simplifying. Now, I mean, it is equal to the correct answer, but my math lab is so picky. So what we need to do is break down that 28. And the reason why I know that it's not going to work is because I've done this before. Haha. But I'm also thinking that 28 will have more numbers than what I'm imagining. So let's do this. So 28, you know what? I want a little bit more room. 28. Does that have a 2 in there? Yeah. 2 and 14. 14, does that have a 2 in there? Yeah, and a 7. 7, does that have a 2? No. Does that have a 3? No. Does that have a 5? No. So that's prime. These are the prime factors of 28. In a way, I can rewrite that 28 as 2 times 7. Oh, whoa, all divided by 4. There you go. Cool. So, why did we do that? It's because I can keep simplifying. In a way, you could say 2 different ways. I got the square root of 4 is going to make a 2. Okay, so that's an easy way to do it. But it's not the way I normally think about it. I say, you know what? There's a pair. There's a pair of the same numbers. And I could pull it out to the outside as a single number. Okay, so that pair of numbers, I think of it kind of like a sports car. How many people fit in a sports car? Come on. Two. Two people fit in the sports car. These two people get together, they fit in the sports car, and they drive off, and they're in the single sports car now. Okay? Seven got left behind. He wasn't a friend, apparently. Just an acquaintance. Um, so mean. Anyways, there's a couple ways to do that, but I'm just like showing you a couple ways. Again, you could say there's a 4 makes a 2, or you could say that it's a pair and pull it out. We're almost done. All of these, I want to use a different color here. All of these have a common number, and if you distribute your denominator and divide them both by the 4, like each one individually by the 4, then what I get here is 2 over 4 is a 2, and then 2 over 4, I just said it wrong. 2 over 4 is a 1/2, and 2 over 4 is a 1/2. And so in a way here, I got 1/2, and then I got a 1/2, and then I got the square root of 7. Now, that works, but surely we can do better than that. And what I'm going to say is that they all have a single denominator. That's a plus and minus still. There you go. Cool. Now, plus and minus should work in my math lab. You don't have to write two separate ones, hopefully. I mean, you could, but then it's like, you know. It's already a long problem. Then you got to do that. What? So I think the plus minus is the better way to do it. Another way at this point right here, you could just say, like, cancel a 2 everywhere. So cancel a 2, cancel a 2, cancel a 2. But remember that basically when you cancel those 2's there, you have to have a 1 as a replacement. And therefore, there's a 1 in the front here. You don't need to write it. Blah, blah, blah. There you go. Okay, so there's a lot of ways to go down that road. That's your final answer. Whew. Word problems. We're not done. I would say blah, blah, blah. Don't really read too much into it other than, oh my gosh, graph it with Desmos. That's what they're saying, aren't they? And I'm going to type it just like you see it here. Just like you see it. With the y equals. And oh my goodness, it works. So x equals what? X equals what? It equals -4. And then a 1. And you're done. Yay. The bigger point is that they're trying to say graph it to find out where these are. Based on this, what's the graph? Well, there you go. We just did it. Desmos. But I want to talk about it a tiny bit too. And it's a B, by the way. If I had to do it by hand, I would, of course, factor. We got a +4 and a -1. So x equals -4, x equals a +1. And that means that on this x-intercept line, we got a -4 and a +1. And they say connect the dots and make sure it's a parabola, blah, 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 blah. So there you go. We just did it. We did it, but it's not as good as Desmos. Desmos is way better. Multiple choice. All right, cool. Last one. And this is a very cool problem. It's also important. I think it was or still is on the chapter applications. So this is an important thing to look at too. Here we go. So it says we got T is players and N is games. And it says we have 55 games. How many players? So I'm basically seeing this as N equals 55. Solve for T. Yeah. So 55 is equal to T squared minus T all over 2. I'm going to multiply that 2 over here to make a 110. Move it to the other side so that it's now going to be equal to 0. And then I factor it. So without going too crazy, what two numbers multiply to 110 but add up to 1? Because essentially there's a 1 right there in the middle. So 110 divided by 10. 10 and 11. To make that -1 right there, I've got to say that this is going to be a -11 and then a +10. And again, you can FOIL and factor and whatever else. It works. And so my answers are 11 and -10. We did it! We're done! Put it in the box, bro. Yeah! Players. Can you have -10 players? No, you can't. So, like, just basically just don't do that. Only positives, because, again, we're talking players, like, as in, like, physical people, and you can't have a negative amount. So, there you go. We did it. I think that's the end of it. Let me just verify right quick that I'm doing everything I wanted. Yep, I did that. So, yeah, by the way, what is it? It's just 11. You're just putting 11, by the way. That's it. All right, cool. And then, yeah, we're done. Cool. That's it. That's all I got. Thank you very much. Have a great day.